Okay, let's look at this question. Consider the first order logic statement, logic sentence, and this big logic, first order logic expression is given. Now they are talking about, okay, psi of s t u v w x y is a quantifier free first order logic formula. So they are talking about this part is quantifier free. All the quantifiers are this only, that they are just clarifying. Okay, now they are saying that using only predicate symbols and possibly equality but no function symbols. Suppose phi has a model with a universe containing 7 elements. Okay, so total number of elements, with total number of 7 elements, there definitely exists a model. Then what can you say about the following statements, like which one of the following statements is necessarily true? Okay, now it turns out that there is it looks like a very sort of absurd sort of question, but the thing is that there's not much to solve here. They're just trying to understand that whether you understand a particular concept. So this concept is that if there you're talking about for all x belongs to x, what do you mean by that? And when you talk about there exist x belong to x, what do you mean by that? If you understand just these two basic things, then you can derive what they're trying to understand, because you understand that these are just statements. There is not much to solve here. If you understand a particular scenario, then you will be able to figure it out what is the correct option. Okay, so we will focus here that for all x and there exists x, what implications we can derive. See, when somebody says you that there exists x belonging to x, then what do you mean? You mean that, okay, size of x is what? Is at least 1. Why? If it is 0 and nothing is there, then you cannot say that there exists some x. There exists some x is true. It means there exists something. At least one element has to exist. But that is not the case here. If somebody says you that for all x something is there and that x is basically empty, let's say empty set is there, then still that thing for all x holds true, because if there is at least one element here and for that it is not true, then the statement is false. But otherwise, if there is nothing, it means there is no one which is going to be violating this statement, and that's why this statement is trivially true. You understand, right? So if somebody says that okay, all apples are rotten in the basket, okay, all apples in the basket are rotten, and turns out that there is no apple in the basket, then will you say that that person is saying truth or saying false statement? What do you say? You will say true, right? Because he is saying that all apples in the basket is rotten and there is no apple, right? So you cannot say that person is saying false, because there would have been a fresh apple in that basket. Then you would say that, okay, that man is not saying the truth. So for all x it is not true, but there is nothing, then that is not a contradiction. So in that say you have to give him a pass that, okay, you are saying correct, right? In that same fashion, I'm trying to say that in this case you cannot say about the size of x can be even 0 also. Now, once you understand this basic thing, then from that you can figure out here. So again, for all x, you can see that you cannot say anything. It can be 0 also, but all these three there exist. Its size has to be 1 at least. This you can figure out, right? Okay, so now we are coming on some path. So when they are talking about there exist s, there exist t, there exist u, right? So at least one s has to be there, one s has to be there, and one t has to be there, one u has to be there. But does that mean that overall 3 elements must be there? Okay, in the universe, is it true? So see, now you can see that the options are making sense, right? There exists at least one model of phi with universe of size less than or equal to 3, right? And then they are saying that there does not exist any model of phi with universe of size less than or equal to 3, right? In that sense, you can understand that first of all, see, there exists at least one model of phi with universe size less than or equal to 3 and no model of phi with universe of size less than or equal to 3. So in that sense, we are definitely going to do something with size 3. So this thing on the face of it, definitely we can say that this is wrong, because about we cannot assume that VU will have particular elements or not. We are concerned with 3, but here it turns out that okay 3, but they are talking about less than or equal to 3 here also, and less than or equal to 3 also here also. Turns out that less than or equal to 3 is the correct answer. So there exists at least one model with universe of size less than or equal to 3. Why? See, basically what is going to happen is that if even for less than 3 elements, this thing can get satisfied. What happens if some s is there, some t is there, and both are equal, and some other u is there? So in this case, basically 2 elements are just there, right? And what happens if, let's say, s and t and u all are equal? So in that sense, just one element is there. At least one element must be there, but 2 can be there, 3 can be also there, right? So say less than or equal to 3 is correct. So the correct answer is that there exists at least one model phi with universe of size less than or equal to 3. The correct answer is A.